z. It's all the integers. And one of those integers is 0. So if that's 0, and I'm talking xx, so that'd be xx, and x is 0, I can't have 0 greater than 0. So it's not even defined. It's not defined. So it's not a relation. It's not an equivalence relation. It's not even a relation, right? Okay. Here's the fourth one. The set is now the real numbers. So your set is the real numbers, and two elements of the real, two reals are equivalent if the absolute difference, and now the reals, remember, is less or equal to a half. What is this relation? Is it an equivalence relation or not? Well, what would your strategy be? You're going to try and prove it? You're going to try and prove it, or you're going to try and disprove it? Which way are you inclined? What do you think? Should you try to prove it or disprove it? Oh, let's try to disprove it. So, now if it's AA, then whatever this is minus, that'd be 0. That's less than half. That's all right. That works. Now BA. Well, since you got the mod of A minus B is the same as the mod of B minus A, so that works. Now how about transitive? If this is not going to work, well, these two work. So if this is not an equivalence relation, then the transitivity criterion must fail, has to fail. Well, let's try something. So if we try 1 and a half, and 1 tilde half, does that work? So this would be 1, that'd be a half. 1 minus a half, the absolute of it is a half, which is less or equal to half. That's okay. So B is a half, we said. And if we leave that at 0, so a half minus 0, that's a half, which is an absolute value, is less or equal to half. That's okay. Now, so is it transitive? Is A tilde C? Well, A would be 1, and C is 0. So that's 1 and that's 0. The absolute value is 1, which is greater than a half. So it doesn't work. The transitive fails. So therefore this is not it's not an equivalence relation. Alright, and the last question, I've done about a third of them, I guess. So your set is the set of triangles, okay? The set of triangles. And triangle A is said to be equivalent to triangle B. So A is said to be equivalent to B if A is similar to B. Do you know what a similar triangle is? It's a triangle. Well, two triangles. They are similar if the second triangle has the same angles as the first. Maybe different sizes. Right? You could take your first triangle and zoom to make it bigger or smaller, right? But all the angles remain the same. So those two triangles of different sizes, they're still similar. Okay. So is that relation? Is that an equivalence relation? Well, presumably A is equivalent to itself. Yes, because all the angles are the same for the two, because it's an identical triangle. So that must be true. So it must be reflexive. Now, if two triangles, if A's similar to B, same angles, well then B similar to A, so it must be symmetric. So B's equivalent to A. So this relation is symmetric. Now, how about transitive? So if you have three triangles now if triangle A is similar to triangle B, and you're given the triangle B is similar to triangle C, well, they all have the same angles, right? So therefore, triangle A is similar to triangle C. So A is equivalent to C. So you have all three conditions met, and therefore this relation here is an equivalence relation. I'll just check that reasoning, if it makes sense. I've left out the last bit. What are the equivalent classes? Well, what are they? Well, if you're given a particular triangle with certain angles, the three angles, then all those triangles that have the same three angles, they will be equivalent to that first triangle. So if you have that would be one equivalence class. And if you had a different triangle with different angles, then all the triangles of different sizes but with the same angles as that second triangle, that would be a second equivalence class. And so you have so each equivalence class is all those triangles that are similar to that particular triangle. So you're going to have an infinite number of equivalence classes. Okay. So the equivalence classes are just the sets of what's the word? Similar triangles. So each set, all the triangles are similar within that set, the equivalence class. Right? So that's the end of lecture 16, equivalence relations. Now the next one, lecture 17, is the big one. It's like the highlight of the whole course on quotient groups, and you'll get a sense of the power of finite group theory once you've finished the next chapter, chapter 17, on quotient groups or factor groups, same thing. A quotient group is the group that you get as the result of a kind of division. Hence, that's what a quotient means. The result after a division. Like, in terms of integers, 17 divided by 5. The answer is 3 plus a remainder. Okay, so 3 is your quotient in a sense, the result of the division. And with quotient groups, you take a group of a certain order, a certain size, and you sometimes can extract from it smaller groups, right? You in a sense can divide groups. Now we've gone the other way in earlier chapters We found, for example, product groups, direct products. You can take two groups, one of size M and the other one of size N, and you form a product group of those two groups and get a much larger group of whose size is M times N, right? So we can multiply groups. We know how to do that. And next chapter, we, under certain circumstances, and that you need to pay attention to that. You need to pay attention to what those circumstances are, but we'll learn what they are in the next lecture. But given that certain criteria are met, then it's possible to extract smaller groups from larger ones. In a sense, you're dividing the larger one into smaller groups, and that in turn allows you to analyze groups for their structure. You can take a group and you can find its subgroups and subgroups and so on. And so it's a very powerful tool. The very concept of the quotient group or factor group allows you to analyze the internal structure of groups, especially large groups. And these techniques that we'll do with the next lecture, next chapter, are used extensively in the following year's course. That's over there on my piano. So if you've enjoying finite group theory at undergrad level and you want to study the same topic at first year masters, what I call M1, then we will be analysing the structure of groups in quite a few chapters. And the theory we will use is the concept of a quotient or factor group. Okay, so until next lecture. Ciao.